Okay, Unit 2, Section 2.1, Polynomials. Hopefully not a lot of this is going to be incredibly new to you. All right, take a minute, do this for me. Give an expression of an example of a linear expression, and give an example of a quadratic expression. We'll talk about the difference in class tomorrow. Okay, so what is a polynomial? A polynomial is an expression in this form. The power of x is decreasing in order. The lead coefficient would be the coefficient to the term that has the highest exponent. We call that highest exponent the degree of the polynomial. The term that does not have an x with it is known as the constant term. Polynomials have no variables in the denominators of fractions. Okay, so 1 over x would not be a polynomial, but 1/2 x squared would still be an example of a polynomial. So you can't have a variable in the denominator of the fraction. You can't have any radicals. So square root of x, cube root of x, x to the 2/3 power. None of these would be examples of polynomials. All powers are non-negative integers. Okay, integers, whole numbers. So it has to be non-negative, because if I gave you x to the -3rd power, although that's an integer, to write that with a positive exponent, it would be 1 over x cubed, which puts that variable in the denominator of the fraction. Okay. Try and list examples of each of these types of polynomials. So polynomials are classified according to their degree. Okay, so give an example of a constant, a linear, a quadratic, a cubic, a quartic, and a quintic. These should not be unfamiliar. Okay, suppose p of x is equal to this function, and I'm going to switch it. Let's make this plus sign a minus sign, because it's going to make the example that much easier. Given this polynomial, 4x squared minus x minus 5, find p of x. If p of x is equal to 0. All right, so let's talk about this. This is a quadratic, because the degree, the highest exponent, is a 2. It is a trinomial, because it's a polynomial with 3 terms to it. And notice this notation, p of x equals 0. So what we're saying is x equals what when y is equal to 0. Okay, so let's make that substitution. 0 equals 4x squared minus x minus 5. Just spent a really long chapter solving quadratics. So this is factorable. That's why I had to change that to a minus sign. Okay, factors of -5, and I need that to add to -1. So -5 plus 1. As a quick check, that gives me -5x. This gives me positive 4x. So that combines to my -1x. -5 times 1 is -5. Okay, so to solve, I get x is equal to 5/4. And setting my other factor equal to 0. I get x is equal to -1. Okay, so what do these values represent? The value of x of the root of the equation, or the value of x of the 0 of the function. And remember what else these terms are. Root, 0. So these x values represent the x-intercepts on the graph of the quadratic, and they also represent the solutions to the equation. Okay, remember these 4 terms are all synonymous with each other. Okay, is the function a polynomial? Yes or no? Give the zeros if they exist. Okay, so A, is this a polynomial? Yes. I don't have any fractions at all, so I don't need to check variables in the denominator. Exponents are positive integers. Let's just list a couple things. The degree of this polynomial would be 4. That's my highest exponent. My lead coefficient, The lead coefficient is not the greatest number. It's the coefficient to the term that has that highest exponent, that degree term. Okay, so this is a polynomial. Give the zeros. So the zeros, the solutions, the roots, the x-intercepts. I set this function equal to 0. I can factor out a 2x squared, leaving me with x squared minus 4 equals 0. So I get x is equal to 0 here, and I'm going to write that as a double root. That'll come up later in the chapter. And then x squared minus 4. If you want to solve this, x squared equals 4, that's fine. Just remember, when you take the square root, two answers exist. So x equals plus or minus 2 would be my solutions from that factor. Okay, part B, not a polynomial. So we don't have to do anything more. Okay, given this function, find p of -3, find p of 2, and find p of 1/2 n. So here's our function notation. Okay, inside the parentheses is our input. So I'm going to set these up. Each of you can solve these on your own without a calculator. Okay, p of 2, so 4 times 2 cubed plus 11 times 2 squared plus 9. Now with this one, wherever you see an x, replace it with 1/2 n. Okay, plus 11 times 1/2 n squared plus 9. So I would suggest pause the video, try these now. Okay, we'll go over them in class.